All right, afternoon, everybody. Let's get going. What do you remember about trig? Number one today, what does the acronym SOHCAHTOA stand for? Anybody remember? That's correct. Sine is by definition opposite over hypotenuse. Yes, that's the SO. The cosine of any angle is by definition, what's the A stand for? Adjacent over the hypotenuse. And T is for tan. That stands for opposite over adjacent. So there's all there is to that. All right. Now, there's three other ones. Last year, we didn't use them at all. This year, they're going to creep in more and more and more. Let's just write all six out. Sine, we just said, was opposite over hypotenuse, correct? Cosine is adjacent over hypotenuse. And TOA, tan, is opposite over adjacent. Slowly, I want you to become more acclimated with the other three, which are just reciprocals of this, okay? So there is something called cosecant. It is sine flipped, okay? I don't even want you to think of it usually as like h over o. Just think of it as sine flipped. So 1 over sine. 1 over a fraction, by the way, just flips the fraction, correct? What's 1 divided by 2/3? Well, don't divide by 2/3, multiply by the reciprocal kind of thing. So if sine was 4/5, for example, what would cosecant be? 5/4. If sine was 3/2, then cosecant would be 2/3. That's kind of all you got to know about that. You got to know cosecant is sine flipped. You also have to know that this other one called secant is cosine flipped. They're kind of backwards, which always irritated me when I first learned them. Like the sine flipped one is the C, and the C flipped one is the S. It's annoying, but that's how it is. Excuse me. Last one actually makes sense. Cotan. Cotan is just tan flipped. So those three, start putting them in your soul slowly. No massive rush, but once you do that, you're okay. That's number 2 on your warm-up. Your warm-up is just number 1 was just right now what SOHCAHTOA was. Number 2 is right now what all 6 of them are. You can combine them into 1 and 2. No worries there. And then number 3 is a softball for you. Well, it kind of depends, actually. By default, if you're doing a math problem, what mode should you be in, radians or degrees? Well, if you're just doing straight up math, radians. Radians is preferred, but are quite often problems given to you in degrees. Yes. So I would say by default, think radians unless the problem is clearly in degrees. If things are in degrees, be in degrees. Otherwise, default to radians. But there will be a lot of problems where they're in degrees, so it just depends back and forth. Make sure you switch your mode. You know where your mode is, right? Mode button, right? And there's one that says radian or degree. Make sure you're switching back and forth as needed, because darn it, we're going to need both in this unit, which kind of sucks. All right, let's do some LGs. Here you go. New semester, new section, all that stuff. Learning goals today. Going to review basics of trig. Basics of trig. Nothing earth-shattering today. Right triangles, SOHCAHTOA, that kind of jazz. Reviewing the definitions of sine and cosine and tangent, and the 3 other freaks, cosecant, secant, and cotan. They do come up a lot because quite often we get tired of writing 1 over sine. You know, why write 1 over sine? Well, let's give it a name. A sine on the bottom is called a cosecant. A cosine on the bottom is called a secant, and so on and so forth. So they have names mostly because, well, they all come from Latin, and you know, where all these trig things, sine comes from sinus, bay, tan, tangier, to touch. They all come from geometric things, but you don't need to know that. You just gotta know what they stand for. So acute and right angles today, straightforward, nothing weird. Let's see what you remember. Hopefully it's a pretty straightforward assignment for you. And here is your assignment. Homework 4.1 is what it will be called. Write it down right now, page 227. 1 through 37 odd, and 47 through 54 all. Nothing too bad. A lot of right triangles today. Right triangles, right triangles. Remember, this is probably the one time, unless you're using like the law of sines or cosines or some other special law, this is the one time you can actually use SOHCAHTOA. SOHCAHTOA is specifically for right triangles, okay? If you don't have a right triangle, you got to go to law of sines or law of cosines, something we'll talk about another day. But if you see a right triangle, do SOHCAHTOA. Okay, here's the title of the new stuff. This is Unit 4, trig functions, in depth, done properly this year. Last year we did hit a lot of trig stuff. And it was in remote too, wasn't it? Okay, so yeah, I think you've seen it in lots of courses prior. God dang it. Oh, we're crying out loud. All right. Well, let's start from scratch. Here we go. Unit 4, trig functions. First things first. This is section 4.1. It's just about right triangles only. So section 4.1, straightforward, start off slow. It will get ugly and complicated. But for right now, we're okay. And let's start off with the basics. Here are your definitions right here that I kind of already put on the board. What is a trig function? They are ratios of two sides in a right triangle. Any right triangle, if you scale it up, and all the angles stay the same, and they're similar triangles kind of things, all the ratios will still stay the same. So if you have a right triangle with a certain angle and certain distances here, and this is 5 and this is 4, we just scale it up by a factor of 3, well, then this side is 3 times bigger and this is 3, but the ratio would still be the same. So please have them all written down right here. If you just want to write down SOHCAHTOA for this first group, that is fine by me. And over on the right, there are the definitions of the 3 other ones that you need to start getting familiar with. Cosecant, do not write out the whole word cosecant, just like you don't write out the whole word sine. You don't write S-I-N-E, you drop the E. Might want to make a reference over here as to what the shorthand way to write them down is. But cosecant, it's just CSC. And it is sine flipped. If sine is opposite over hypotenuse, then flipping that would be hypotenuse over opposite. So that's what cosecant is over there. But I'd much prefer you kind of just write down what I wrote. Cosecant's 1 over sine. If you know that, if you know what sine is, now all you got to do is flip it, and you got yourself a cosecant. Same with the middle one on the right. That is secant. Secant is cosine flipped. If cosine's adjacent over hypotenuse, then secant is hypotenuse over adjacent. But again, probably just better to know that secant is cosine flipped. And then the last one, cotan, that actually makes sense. COT is how you abbreviate that one. It's tan flipped, 1 over tan. And if tan's opposite over adjacent, then that would make cotan adjacent over opposite. Any questions over those? Okay. Don't want to spend forever on it, but that's kind of the main things. These are trig ratios here. We got your SOHCAHTOA. Might want to write down that real quick. And let's do something. Here we go. Let's write down this triangle. Draw a picture of that triangle on the top right. We're just going to practice finding all these ratios. Start with the basics. 8, 15, 17. All right. All these are always, of course, referencing a specific angle. What angle are you using for this thing? For us, they're saying sine of theta. In the picture, theta is in the bottom left, correct? Okay, so we're going to dive in, and we're going to go ahead and see what all these ratios might be. Here we go. Right off the bat, sine of this angle. Do you need to know what the angle is? Nah, I don't care. I can figure it out, but I don't care. Sine of this angle, by definition, what's sine? Opposite over hypotenuse. Remember opposite and hypotenuse and all it means? Hypotenuse is the longest one, correct? So 17 is the hypotenuse, and the opposite and the adjacent depend on what angle you're talking about. If I'm talking about this angle, what side is opposite this? 8, yes. So it's 8 opposite over hypotenuse, and the hypotenuse is 17. So if somebody asked you to find the sine of this angle given in this triangle, your answer would be 8/17. Similarly, if they ask you for the cosine of this angle, what's cosine? By definition, adjacent over hypotenuse. Adjacent means next to. Now, any of these angles, there's 2 sides next to it. But one of them has already got a name. The longest one is hypotenuse, right? So the other one is the adjacent. So for this angle, 15 is my adjacent. And again, the hypotenuse is 17. So the cosine of this angle would be 15/17. And so on and so forth. Tan, by definition, opposite over adjacent, right? So the opposite side of my angle is 8, and the adjacent side is 15. Now, I would not want you to go through all this logic again for the other 3. Okay, you should know they're just flipped. So cosecant which one is flipped for cosecant? Which one gets flipped for cosecant? Sine does. So sine was 8 over 17, then cosecant is 17 over 8. It's very quick once you get the 3 basics down. And I always try to line them up like this too, so you see which ones pair with which. Secant, yep, is cosine flipped, so 17 over 15. And lastly, cotan is tan flipped, which would be 15/8. So it's about that easy. That's all you should have to do to find all 6 trig functions for any given angle. If you know all the sides, pretty straightforward. Any questions over that? Think it makes sense? All right, let's go back to the stuff then. So how about down here? I'll just give me one of them. Find me tan of this angle. 5/12, right. What would cotan be? 12/5, right. Down here, find me cosecant of this angle. Now, what's cosecant? Which one flipped is cosecant? Sine. So can you find sine in your mind real quick? What's the sine of that angle? Opposite. 21 over 29 for the sine, right? So 29 over 21, exactly, precisely. That's all there kind of is to it. Let's do this one. Write down the words for this one. Yes. Today's won't be too bad, right? Today will be pretty straightforward. They will still throw some weird terminology at you, though, or just kinds of problems. So I do want you to write down this one, because this one's a weird one that might come up your way. It's not hard once you get it figured out. If they give you a cosine, they flat out tell you the cosine of some angle is 2/5. But they don't give you any triangle or any picture. And then they also say, hey, go find all the 5 other ones. If you got cosine, could you find sine and tan and cosecant? And how? How could I find the other ones if this is all I got? Well, let's make a triangle. Yeah. Doesn't matter how you draw your triangle. I'll draw it like this. Doesn't freaking matter. A little 90-degree symbol in here. It doesn't matter. Now, all they gave me to go off was cosine, right? But what is cosine? By definition, cosine is what? Oh, well, that must be the adjacent, and this must be the hypotenuse. So wherever you drew your angle, it doesn't matter, but the adjacent side must be 2, and the hypotenuse must be 5. How could I find the missing side? Pythagorean theorem. Yep, don't forget your Pythagorean theorem. So what's Pythagorean theorem say? This squared plus that squared equals that squared. So 2 squared, 4, plus the unknown. What do you want to call the unknown? B? I heard B first, so we're going to do B. 4 plus B squared equals 25, right? So B is, yeah, if you take a plus or minus square root of 21, but in practice, these are lengths, correct? Lengths of the sides. So you just want to always use the positive version in this case. So this is one time when forgetting your plus or minus is okay. So B is the square root of 21. Can we simplify that any? By the way, we're pre-calc. I don't think we can. Nothing perfect goes in that. So square root of 21. Now you got a triangle, don't you? Now you can find the other 5 just like we did in the last problem. So if I ask you for sine of this angle, it'd be opposite, which is square root of 21 over the hypotenuse, which is 5, right? And so on and so forth. We need tan. Tan would be opposite over adjacent, so square root of 21 over 2. And then we got the 3 basic ones, cosine, sine, tangent. All we got to do is flip them to get the other jerks. So how about cosecant? Cosecant's what flipped? Sine. Sine was square root of 21 over 5, so we'll call that 5 over square root of 21. Now, the older you get, the less I care about this. Math textbooks usually don't like a square root on the bottom, do they? Remember that crap? So I don't care if you're turning it on, paper, if you leave it like this, but just so you know, they might want you to multiply the top and bottom by that root and get the root on the top. I don't care if you do that or not. It really is a pointless step of this. They teach you that when you're younger, and then they get older and they say, well, that's dumb. Why are we even doing that? And I kind of agree. So I'm totally okay with that answer right there. How about secant? What flipped is secant? Yeah, it's 5 over 2. It's cosine flipped, so 5 over 2. And lastly, cotan is tan flipped, so 2 over square root of 21. That's all there is to it. Nothing earth-shattering today, would you agree? Good. Let's keep going then. Here's some common angles. You don't need to memorize that right now. I'll give you a graph. Did I ever give you a graph of the trig things? You're going to use that one a lot. So if you don't have it, get it from the website or something like that, but that's okay. Let's actually solve a problem. This one has no triangle given, but it says solve this thing. Find the value of x. How would you go about doing this? You tell me. Let's write this one down. Write that down. Write down your little triangle there. Top right, yeah. Top right, dude. X is on the bottom. It's a 42-degree angle given. And you also have a hypotenuse of 18. Now, how would you go about solving for x? Well, here's the key. Here's the thing. How do you know which one to pick? You got 6 trig functions to pick from. First of all, which 3 should you avoid like the plague? These ones, yeah. Try not to use those unless, absolutely necessary, because you can always flip them, right, and turn them into those. So stick to your 3 basics if you can. But cosine would be the correct one to pick. Why cosine? Yep, you got to relate what you want to something you know, right? So you want the adjacent, you got the hypotenuse, A and H. I agree, cosine. So cosine of, now this time we have a specific angle, 42 degrees. So when I go solve this, I better damn well check that my calculator is in degrees. But by definition, it's the adjacent, which is x, over the hypotenuse, which is 18. And then all you got to do is multiply by 18, correct? So x is going to be 18 times the cosine of 42 degrees. You just type that in your calculator. Make sure you're in degrees. What'd you do wrong? Yeah, I know. Yeah. 13.37. Sounds plausible. Anybody want to confirm that? Confirmed. Okay. 13.37. Check. So we just solved for a missing side of a triangle. That's how you solve for it. Notice that if 2 things are given, you can figure anything else out. What if this was given? Well, here's 2 things, aren't there? Could we figure out this side? Yeah, could we figure out that side if we want to? Sure. As long as they give you 2 pieces of information, you can figure something out to solve it, and that'd be just fine right there. All right, that wasn't very bad. Let's see if we can do another one like that. Yeah, how about this one? Down here at the bottom. You have a little right triangle, and you got the angle here. Which one would you pick? Sine, cosine, tangent? Which one would you pick? Tangent, yeah. So your setup would be tan of 21 is 9 over x. You buying that? Oh, man. Tan of 21 is 9 over x. How would you solve something when there's x's on the bottom? Multiply through by x. And then divide by tan, right? So your final answer would be x is 9 over tan of 21. Or you could say 9 times the cotan of 21, because that's what 1 over tan is, right? There'd be no need, though. Your calculator, by the way, do you see any cosecant buttons or secant buttons? Or no. And there's a reason they'll put this on there, because they're just, these 3 are just these other ones flipped, right? So if you can find, if somebody asks you to find cotan of 42 degrees, don't go find cotan of 42 degrees, find tan of 42 and then just flip it. That's all there is to it. All right. Hopping right along, there are inverses. Okay, we're going to do these a lot more this year. What's an inverse do? It undoes something, right? Okay, so when would you use a sine inverse? When you have a sine. When would you use a tan inverse? When you have a tan. That's pretty much all there is to it. Well, we'll get a lot more in depth in the future. But for right now, just remember that you can use these to solve for angles. Got it? Inverses solve for angles. So if you have some sides known, you can solve for an angle. Let's see if we can do that here. Let's copy down this top right one here. This looks interesting. Use a trig function to measure the angle of this theta. So let's draw this little stupid thing. There's theta. 11 and 26. Now you don't know the angle. Nonetheless, what information do you have for the angle you're missing? The opposite and the adjacent. So I'm really thinking maybe we should play with what? I would agree. So we dive in with that. Tan of the angle, which you don't know, so you just write tan of the angle, but you know it's equal to the opposite, 26, over the adjacent, which is 11. Now the theta is inside of this function, you know, it's inside of this tan. So how do you undo this function? Well, what's the inverse? What's the inverse of tan? Tan inverse. So you do tan inverse of both sides. Tan inverse of this side, tan inverse of this side. And what's the tan inverse and the tan do? Cancel out, just like an exponential log or a square and a square root. By design, they're going to cancel out. So your angle is whatever tan inverse of 26/11 is, which you can type in your calculator. What is 67? I buy that. About 67 degrees-ish, correct? Sweet. So that's really what inverses are good for. They're good for solving for angles when you don't have them. What trig thing would you set up for this? We won't do the whole thing, but for the bottom left one, what trig function pops to mind with 14 and 16? Sine, I would agree. What about this one right here? Cosine, you know the adjacent on that, and you can just do an inverse real quick and solve for them, correct? So nothing too bad there. Boy, we're zipping right through this. Last thing, okay? There might be a problem or two about flight. Now, this is nothing complicated. It's just vocab terms, okay? You might want to jot down this picture real quick to know what they're talking about. Okay. When somebody says angle of elevation, they mean at what angle above the horizontal you're shooting at. So angle of elevation is the angle that the line of sight is above the horizontal. Somebody up in the air, though, might look down, and this angle below the horizontal, for somebody else, is called your angle of depression. So really, you just got to know angle of elevation means an angle that's pointing upwards. Angle of depression is an angle pointing downwards. That's all that this stuff means. If you can know those terminologies right there, then if they give you a rinky-dink problem involving something where it's at a certain height above the ground, an angle of elevation of something, you can figure out how far it is this way and how far it is that way and everything else. So you just got to know your vocab terms. And that's about it. One last thing. When they say solve a triangle, does anybody remember what that means, to solve a triangle? Find everything, right. So that last little section of your homework, the 47 through 54, something like that, is one where I ask you to solve the triangle and just go find every dang thing. Let's practice doing one, and we'll call it a day. I think that literally is the last one. So let's write down this example. Write down your little triangle with X's and all that crap. Starting off nice and slow, back from break. Isn't that nice? They're writing their angles out. Well, what are they labeling these vertices? This is stupid. I'm gonna do that. Good enough. I don't need anything else for that. I believe it's 35. Yeah, 35. All right, you don't need to label the other sides. They're kind of pointless. Here's the missing sides, correct? Although we do have this angle down here. It has a name, doesn't it? What's the name of that? Y? Yeah, okay. So I guess we could call it Y or something like that. How could you find Y right off the bat? They all have to 180. Very good. So take 180 minus 90 minus 35, and what do you get? 55. Okay, so we got that angle. Check. 55. Score. We got all the angles, don't we? Nice. Now we just got to find all the sides. Okay, you want to go tan. Why do you want to go tan? What are you solving for? Okay. Tan of 35, by definition for the 35, opposites, x, adjacent is 10. Down with that. There's only one thing unknown, right? Multiply through by 10, plug in your calculator, and tell me what you get. Exactly?
It's like 7.0020.
Okay, that's pretty darn close, yeah. Okay, x about 7. Round to the nearest 10th or 100th or something like that, normal business, okay.
Yeah,
Sure.
Does it matter what angle you pick?
Absolutely, it does.
So why would it be 55?
Well, we picked. It didn't matter. You can pick whichever one you want.
Oh, okay.
So we arbitrarily went 35. You're fine. Yeah. Let's go the other way. What'd you get for 7.02, right? Let's try. What if you picked 55? If you were trying to solve for x with 55, you know the opposite and the adjacent, don't you? Yeah. So let's see here. Tan of 55 would have been 10 over x, correct? And then we have to multiply by x, wouldn't we? And then divide by the tan of 55. So maybe somebody else would have got that. I wonder what 10 divided by the tan of 55 is. Probably 7.002, and it is. So that's a good question. Does it matter which angle you pick? Nope. Pick whichever one you want. It's all going to work out the same. Okay, z. Let's find z. Now, you could do Pythagorean theorem. I would not recommend Pythagorean theorem because this is not a nice clean number, is it? So let's just do some trig thing again. Which angle do you feel like using? You want to use 55? Okay. So 55, you want to do sine? Works for me. Because we know the opposite. We don't know the hypotenuse. So sine of 55, yep, is opposite over hypotenuse, which is z. Multiply through by z, divide by the sine. And lastly, you're going to get whatever 10 divided by sine of 55 is. 12.02-ish. 12.21. My bad. All right. So that's about 12.21-ish. We have all the angles found. All the sides found. Triangle's been solved. Okay, so that's all for today. Pretty easy, right? I think it's just a good refresher of SOHCAHTOA, but start getting those three sister functions in. Secant is cosine flipped. Cosecant is sine flipped. Cotan is tan flipped. Got some time left? Go and get started on your homework. Yes, ma'am. You're welcome to come look at it if you want. I will not hand them back. They're by request only to view. Sure. You want to go to the bathroom first?
No.
Okay.
I can wait. I'm pretty sure it's still that way too.
Sure. Let's see what we got.
Because I know, apparently, according to my dad, that I did good enough for my final to take my grade from a D to a C. So.
Yeah, that's a big jump. Yes, sir.
59 points.
Yes, you may. You do? Okay.
Yeah, so I haven't taken any of my final.
Glad I didn't throw these away.
Yeah.
I think I did. I hope so. Oh, good, or else I think I just said you can keep it or something. Okay, that's fine. Yeah, that's okay.
Hey, at least I got that part.
What part?
So,
I don't know, something. What's that right above there? What are you doing? What are you doing?
I don't know.
Okay.
I honestly have no idea what I did.
Nor did I.
I thought I did pretty good. Oh,